Okay, good morning, class. All right. Okay, it has been 1 week. We didn't have class. Okay, so last lesson we have finished scalar product. Still remember? Or we call it as dot product. All right. So I hope you still remember. Okay, dot product. Or we call it scalar product. In Cartesian form. All right. If scalar product A dot B equals 0, then it's two perpendicular vectors. If A dot B and then scalar product is commutative, A dot B same as B dot A. All right, and it's distributive. All right, but non-associative. And remember, if two scalar product, if the scalar product of two vectors, of two parallel vectors, all right, if they are parallel, then A dot B equals to modulus A modulus B. All right, so this scalar product, and scalar product is actually equals to a scalar. The answer should be equals to a number, right? Okay, so today we will see another one, which is called vector product. All right, so today we will go to vector product. Right, so what is vector product? From the name, actually, you know, scalar product, the answer is a scalar, is a number. So vector product, so the answer should be another vector. All right, okay, so let's see what is vector product. So 6.1.3.6 vector product. All right, so the vector product, or we call it cross product, okay, of two vectors A and B is denoted by like this. Okay, so we say A cross B. We don't say multiply. All right, it's not multiply, it's cross. So we say A cross B. So that's why we call it cross product, okay, or vector product. Okay, sometimes some reference book they write it in this form. All right, A hat B. But this one we seldom use lah. Okay, so the cross product A cross B will be another new vector. All right, this A cross B is represent a new vector which is perpendicular to both vector A and B. Excuse me. All right, this means that the vector product is defined only when A and B are three-dimensional vectors. Also, vector product only can do for three-dimensional vectors. If two-dimension, we can't do it. All right. So, by using a diagram, then I can show you the concept. All right, let's say I have two vectors on this plane. Okay, this is not necessarily a horizontal plane. All right, so this plane can be vertical like this, can be slant like this. All right, so this A and B lies on the a plane. All right, so plane can be any direction. So now I just show it in horizontally. Okay, so let's say this is vector A and vector B. Remember, in the scalar product, the dot product, the two vectors A and B must diverge from a point or converge to a point, right? So let's say this is vector A and vector B. All right, so what is vector A cross B? So just now we say A cross B is another new vector, and this new vector is perpendicular to both A and B. So imagine this red color pen will be your A cross B. All right, so if vector A and B is on this plane, so this red color pen will represent A cross B, where A cross B is perpendicular to A and also perpendicular to B. All right, so the red color pen represent A cross B. All right, so this is a concept for vector product. All right, okay. And what is the formula to calculate A cross B? So remember, dot product, the dot product, scalar product, A dot B is modulus A modulus B cos theta. Remember? So vector product is this one. Vector product is modulus A modulus B but sine theta. And just now we say, right, A cross B is another new vector. So it cannot be a scalar, it should be a vector. So it's multiplied with n hat. N hat is a unit vector. All right, so let's see the definition for this formula. So what is theta? Theta is the angle between A and B, measure anti-clockwise. All right, so by using the example just now, so if this is vector A, this is vector B, then the angle theta should measure from A to B because we are looking for A cross B. If we're looking for A cross B, all right, then should be measured from A to B anti-clockwise. So from A anti-clockwise to B. So this is theta. All right. Okay. And n hat is a unit vector. Remember, hat means a vector with the modulus 1 unit. Okay. So n hat is a unit vector in the direction of A cross B. Therefore, this n also perpendicular to both A and B as shown in the diagram below. All right, so this diagram is a bit dark. Okay, all right, so I will draw another. I have drawn another one and show you. Okay, so just like this. So let's say A and B are two vectors on the same plane. So the vector that perpendicular to A and B will be your A cross B. So the red color one is the vector product. Okay, A cross B. All right, and n is another vector parallel to A cross B. See that? In the direction of A cross B, but it's only 1 unit lah. The magnitude is only 1 unit. All right. So this is n. And in the actual calculation, actually we didn't have to calculate n. Don't worry about it. All right. Okay. So n is a unit vector in the direction of A cross B and perpendicular to both A and B. All right, so this is the diagram. Okay, by the right hand rule, we find that the unit vector n and the vector A cross B are perpendicular to the plane. So the unit vector n and the vector A cross B are the normal vectors that points the way your right thumb points when your finger twists through the angle theta from A to B. So it means that if you use your right hand, so when you grab your hand, so you see the direction is anti-clockwise. From A, hold on. Okay, that's the paper. Okay, from A, okay, when you grab your hand, it's anti-clockwise to B. Then you put your thumbs up. So this thumb show the vector product. All right, the A cross B. All right, so this is what we call the right hand rule. All right, or we can say that this one, other than this right hand rule, we also can use this one, the right hand system. All right, also can show the unit vector n and the vector product A cross B are perpendicular to both vector A and B. So these two fingers will be your A and B. A and B. Okay, A, B. Then your thumb will show A cross B, or actually also same direction as n. Okay, so both can be used. All right, so now we know what is vector product. Okay, let's see the properties of vector product. Okay, so for the vector B cross A, so the angle theta is measured clockwise. Theta is become the negative angle already, like this one. Just like if we measure this direction, then A cross B. All right, so if B cross A, B cross A means from B to A, right? So from B to A, then it become clockwise. All right, it become clockwise. So just now, A to B anti-clockwise, the theta is positive. All right, so if B cross A, so become from B to A, then it become clockwise. So the angle will become a negative angle. All right. So for B cross B, for B cross A. All right. So the angle theta is measured clockwise, right? So it become negative angle. Hence, by using this definition, all right. So B cross A will be modulus B modulus A sine negative angle, negative theta, and multiplied with unit vector n. Okay, so we know that, remember the negative angle formula? Sine negative theta same as negative sine theta. So we put the negative out. Sine theta equals negative sine theta. So negative sine theta. All right, modulus A multiplied modulus B, I can write as modulus A multiplied modulus B, right? Okay, so by using the definition, so modulus A modulus B sine theta n unit vector n, so it's actually A cross B. If B cross A, modulus B modulus A, so if A cross B, modulus A multiplied modulus B, then it's A cross B, but there is a negative in front. Okay, so this line show you that B cross A equals to negative A cross B. Therefore, vector product is non-commutative. All right, not same as scalar product. Scalar product is commutative. A dot B same as B dot A. But for vector product, B cross A doesn't same as A cross B. It's equals to negative A cross B. Or we say A cross B equals to negative B cross A. So they are non-commutative. All right, so this is the first property of vector product. Okay, the second property will be vector product is distributive. Yes, it is distributive. Let's say A cross B plus C. So remember, B plus C is another new vector. So vector cross vector. So remember, vector product also vector cross vector. All right, so it's distributive means we can expand it as A cross B. All right, center is plus, then A cross C. All right, so it's distributive. It is very useful. You must memorize it. Okay, number 3. Let's say if I have two parallel vectors. So what will happen to A cross B? All right, let's say A and B are two parallel vectors. All right, if parallel and same direction, then the theta is 0, remember? Okay? If parallel and same direction, theta is 0. So sine 0 is 0, right? Therefore, your A cross B equals 0. All right? If same direction, theta equals 0. If opposite direction, theta equals 180. But no matter it's 0 or 180, for sine, the sine 0 theta and sine 180 theta both are equals to 0. All right? Therefore, if you have two parallel vectors A and B, then the cross product will be equals to 0. Okay? So the fourth one, if two vectors are perpendicular to each other, so theta is 90, and we know that sine 90 is 1. Okay? So when I sub into the formula, here also can. When we sub into the formula, sine 90 is 1. Therefore, A cross B same as modulus A modulus B and unit vector n. Alright, no need sine theta because sine 90 is 1. Alright, so when we get this one, when we add modulus to both sides, so it will get modulus A cross B same as modulus A modulus B because this is unit vector. So the modulus of a unit vector is 1. So we can, we just don't write it. Alright. Okay, so you must memorize these 4 properties of vector product. Alright, first, it is non-commutative. A cross B equals to negative B cross A. B is distributive. C, if parallel, A cross B equals 0. And D, if two vectors are perpendicular, then modulus A cross B will be equals to modulus A multiplied modulus B. Okay, so this is the concept of vector product. Okay, so now we will see how to do calculation. All right, how to do calculation of vector product in Cartesian form, means in IJK form. All right, so it's like this. So from the vector product of two vectors, so this is a formula, right? A cross B is modulus A modulus B sine theta n hat. All right. Okay, if you know that I, J, K are the unit vector in the direction of x-axis, y-axis, and z-axis. So what happened to I cross I? So I cross I is modulus I sine 0 because I and I are parallel and same direction. All right. So everything become 0. Therefore, J cross J also 0. K cross K also 0. All right. So we are using this concept. Right? If two vectors are parallel, then the vector product will be equals to a 0 vector. All right? Okay, number 2. Since vector A cross B is perpendicular to both vector A and B, and the unit vector I, J, K are perpendicular to each other, right? Now, this is I, this is J, this is K. They are perpendicular to each other. All right? Then the vector product of two units vector can be obtained. So now we want to find the vector product for ijk. Okay, so we have two different conditions. One is we multiply ijk clockwise. All right, so means that ijk will be arranged like this. Ijk, we write it in a circle, ijk. If it is clockwise, follow clockwise, I cross j, j cross k, k cross I, like this. All right, then the product will be positive. Okay, means ijk arranged in clockwise direction. So I cross j will be k, because k perpendicular to I and j, right? Therefore, j cross k will be I. So you see, I cross j is k, j cross k is I. All right, and k cross I is j. This is how we get this. Okay. So the second condition is if we multiply it anti-clockwise. So you see, we still write ijk in the same position, but now we're going this way, anti-clockwise way. So means I multiply k, k multiply j, j multiply I. All right, so I multiply k will be negative j. It's same here, you see. K multiply I is j. So I multiply k will be negative j. Remember this? It is non-commutative. We are using this concept. All right. So k multiply j, negative I. J multiply I, negative k. All like this. I multiply, not multiply, sorry, cross. Okay, not multiply, cross. I cross k is j. K cross j, sorry, again. I cross k, negative j. K cross j, negative I. J cross I, negative k. All right. So if clockwise, your answer is positive. If anti-clockwise, your answer is negative. Okay. Sometimes we will need this result to do our solution, to get the solution. All right. So next. Okay. All right. So next will be like this. So let's see. Excuse me. Now we see the calculation for vector product. Okay, let's say you are given two vectors A and B, given in the ijk form. X1, Y1, Z1. B is X2, Y2, Z2. So applying the law of distribution. So A cross B. So this is A cross, this is B. All right. So we will use this first term, multiply these three. So x1i multiply x2i. So become x1, x2, I cross I. All right. Because cross must be vector with vector. X1 and x2 are scalar only, so we can put the scalar outside. All right. Then x1i multiplied with y2j. So x1, y2, I cross j. All right. Then x1i will multiply z2k. All right. So become x1, z2, I cross k. All right. Then next will be use the second term, y1j. Y1j multiply these three. So you get this one. All right. And the third one, you use z1k to multiply these three. So you get these three terms. All right. So now, let's see. So remember just now what we have said? Okay. I put it here. Just now the result that we get. I cross I is 0, right? Just now we say. So this one 0. Okay. J cross J also 0. So this one also 0. Okay. K cross K also 0. So this one also 0. So these three terms eliminate already. All right. Left. X1, Y1. I cross J. So I cross J is K. See? So Y1, X1, Y2. I cross J. So become K. So x1, y2, k. All right. This one I cross k. All right. I cross k. This is k cross I. So I cross k negative j. All right. So you see negative j. Okay. So this one y1, x2, j cross I. So y1, x2, j cross I. So j cross I cross j is k. So j cross I, negative k. So you see, it's negative in front, k. All right. The fourth one, j cross k. J cross k is I, positive I. All right. So y1, z2, I. All right. Yeah. Okay. Then this one, K cross I. K cross I is J. So you get J here. This one K cross J. J cross K is I. So K cross J, negative I. So again, negative I. All right. So we factorize the term I and I. So you see I and I here. All right. So it's y1 z2 minus z1 y2. y1 z2 minus z1 y2 I. And then terms in J here. J, this one. All right. So we use z1 x2 minus x1 z2 here. Factorize them. Then J. Okay. And for terms in K, this one and this one. All right, so x1 y2 minus y1 x2 K. Okay. All right, so this is how you get to this line. Okay. Okay, so this line, the I component still the same. All right, so for the J component, we factorize out the negative. Later you will know why we want to arrange it. We factorize out the negative. So this one negative ma. So this one negative become positive lah. We just rearrange only. The K component still the same. All right. So why we do this? You see, when we get this thing, I can actually write like this. Still remember the determinant? We are using the concept for matrices. All right, so I hope you can do a little bit revision for matrices. All right, we use the concept for matrices. Still remember the determinant of matrices? If you have a 2 by 2 matrix, 2 by 2 matrix, the determinant is y1 z2 minus y1 z2 minus z1 y2 from here. Yeah, so this one also. The determinant is actually x1, x1, x2, z1, z2. So when you find the determinant is x1, z2, this one, minus z1, y2, z1, x2, this one. This is why we want to rearrange this second term in this way, so that it become a determinant. All right. So for the K component also, we write it in the way x1, x2, y1, y2. So the determinant is x1, y2 minus y1, x2. See? Yeah. So from this step, they actually related it to the determinant of the matrix. All right. So this is for one determinant 2 by 2. And this whole line, this whole thing, is actually the determinant of a 3 by 3 matrix. All right. This is the determinant for 2 by 2 matrix. And this whole thing, when we combine these three terms, is actually the determinant for a 3 by 3 matrix. So I hope you still remember, when you have a 3 by 3 matrix like this, to find its determinant, this is not modulus anymore, this is determinant. Determinant, it's not modulus. Okay, so don't confuse. Okay, don't confuse. This is not modulus, but this is determinant, to find the determinant. All right, so remember, if you have a 3 by 3 matrix, how to find its determinant? We choose first term, then we cross the row and the column, remember? So this left a 2 by 2 matrix. Okay, and the component is I. All right, I hope you still remember. And to calculate the determinant of a 3 by 3 matrices, remember the sign for the minor, then become cofactor. The sign for the first term positive, the sign for the second term negative. Remember? This is why we want to write it in this way just now. Okay? Then third term, the sign for third term is plus. So if you choose K as the subject, then remember we cross this row and this column. So left this 2 by 2 determinant. X1, x2, z1, z2, and multiplied with component J. So I hope you still remember the determinant of 3 by 3 matrix. So do the K. So when you see K, then you cross here and here, then you get this 2 by 2 matrix. All right? Therefore, from the beginning, A cross B, we write it in IJK form, using distributive law to expand it, then simplify them, okay, simplified them, and from the simplified form, we found that it is actually the determinant of a 3 by 3 matrix. Oh, it's so fantastic, mathematics. Okay, therefore, from here, we know that to calculate A cross B, you have to find the determinant of these 3 by 3 matrices. All right, so the first row will be your IJK. Second row will be the IJK component for vector A. All right, third row will be the IJK component for the second vector. All right. So actually, vector and matrix, they are quite close to each other. Okay. So this is overall the concept for vector product. All right. Okay, so we will see some question. We will see some example so that it will have clearer picture. All right. So most of the question will come from checkpoint 6.3. So you please open your textbook, checkpoint 6.3. Okay, my one is page 266. All right, 266. So I show you the question. Okay, so I hope you can see well. All right, brighter. Okay, so this is a question. I'm going to discuss question 1 to, not discuss all lah, but we are going to do question 1 to 7, which is related to vector product. Okay, another 3 question will be another related to another small part. All right, so this is a question. Okay, so let's see one by one. Okay. So I will discuss question 1. Okay. All right. So I will discuss question 1A and B. All right. So find the value of A cross B of each of the following vectors. So we are given for question 1, A is 2i plus j plus 4k. B is I minus 3j plus 2k. So find A cross B. So just follow the method that we have discussed just now. Okay, all right. So you are given vector A and vector B. So A cross B will be the determinant of a 3 by 3 matrix. So first row will be your IJK. Second row is the IJK component for vector A. So 2, 1, 4. So 2, 1, 4. All right. Third line will be the IJK component for vector B. So 1, negative 3, 2. 1, negative 3, 2. All right. So this is first first question. So I show you in details way. So first one is I. All right. So I cross this row and this column. So left a 2 by 2 matrix. 1, 4, negative 3, 2. Like this. Okay. And remember second is minus. Must be minus. Okay. So second will be J. All right. So I cross this row and this column. So left 2, 4, 1, 2. This one. All right. So the third one is K. Okay. So cross this row and this column. So left 2, 1, 1, negative 3. Okay. First time I write in this way lah. So actually you want to write in this way also can. If you are not really sure, then please write this one out. Then only you do. If you think you are already better, then from this step you can come to this step. All right. Okay. So this is to find the determinant of this 2 by 2 matrix. Very simple. This one multiply this one minus this one multiply this one. So 2 minus negative 12. I. Okay. 4 minus 4. J. Negative 6 minus 1. K. Alright. So this is 14I. This is negative, but 4 minus 4 is 0, right? So no J component. This is minus 7. K. Yeah, this is your A cross B. Remember, A cross B vector product. So the product is another vector. Okay, so for question 1B, so you are given vector A 3i minus 2k. No J component, so means 0 lah. Vector B is minus 2i plus j minus 3k. Alright, therefore your A cross B Okay, I push it up a bit. So A cross B will be a matrix, first line ijk, second line, the component for vector A. So 3, 0, -2. No J component means 0. Okay, vector B is -2, 1, -3. Okay, now I skip this step. Okay, so I straight away come to this one. So imagine you cross here and here. So left this 4. So 0 minus -2, so plus 2. I. Okay, for J, cross this one and this one. So -9 minus 4. Okay, minus, remember, component for the second term is negative. And then component K, cross this one and this one. So left this 4. So 3 minus 0. Alright, so for question B, A cross B is 2i plus 13j plus 3k. This is -13 but this is negative, so positive. Alright, so this is how you calculate your vector product. Alright, not difficult. Okay, so this is question 1, A and B. So C, you do it as homework, okay? Alright, question 2 also I want you to do yourself. Not difficult, you see. You are given vector A and vector B. Verify that A cross B same as negative B cross A. Remember, this is not rules. This is not a property. This is only this one only true for these two vectors. Okay, this question, don't confuse. This one only true for these two vectors, not for any vectors. Alright? So they want you to verify this. So what you can do is, you find A cross B, like just now. Then you calculate negative B cross A. What is negative B? This is B. Alright, this is B. So negative B means negative I plus J plus 2K. Correct that? So use this one, calculate the right hand side. Then you compare. They should be the same. Alright, so this one you can do yourself. Okay, question 3 also you do as homework. You see, you are given vector A, vector B, and vector C. You see vector B is 2i minus j, no k, so k is 0 lah. C is j minus 2k, no I, so I is 0 lah. So you're asking to verify this one. This one involves dot product, see? Dot product. So they want you to show that A dot B cross C, same as B dot C cross A, same as C dot A cross B. Alright, so so means that you have to calculate these 3. Alright, you have to calculate these 3 parts and show that they are all the same. The answer should be all the same. Alright, so how to do, I show you the first one, this one. You have A dot B cross C. Okay, remember, dot product must be vector dot vector. Okay, cross product also must be vector cross vector. So which one you are going to do first? Are you going to do the dot first or the cross first? Okay, remember, if you do dot first, what is A dot B? A dot B is a scalar, right? Remember, A dot B is a number. Let's say it's lambda lah. So can a number cross a vector? Can a number cross a vector? Yes. Cannot. Right? Cannot. So you know that you are not going to do dot product first. So means that you have to do cross product first. You have to do the cross product, because vector product or cross product, the answer is another vector. So vector dot vector can do. Alright? So remember lah. Okay? So you do these 3 parts separately. Then their answer should be the same. Alright? So I hope you still remember how to do the dot product. So do it as your revision. Okay? Okay, number 4. Given that vector A, B, and C. Okay, again, they give you vector A, B, C. Okay, calculate A, B. So calculate A cross bracket B cross C. So this one is only cross product, so no problem. This is in bracket, means you have to calculate this one first. Calculate B cross C first. Then, it's a new vector, right? So A cross this new vector. But else this one is bracket A cross B first. So you cross A cross B first. Then you get a new vector. Then use this new vector, cross your C. Alright? So after you get your A and B, you see what conclusion can you do? This is associative. If they are the same, then associative. Alright? If they are not the same, means they are not associative. I hope you still remember associative law. Okay? So 1C, 2, 3, 4 you can do. You please try on your own. Okay? Alright, so I'm going to do question 5. Okay, question 5. I'm going to discuss question 5, 6, 7. Alright, okay. So, we do it faster. Okay, question 5. You're asking to simplify these 4. A, B, C, D. Simplify them. Okay, number 5, A. A dot A cross B. Okay, how to simplify this? This one. Okay, can see A dot A cross B. Alright, so remember, A cross B is a vector coproduct. And just now we already say that A cross B, this new vector perpendicular to A and also perpendicular to B. Remember? So A cross B, this is a new vector. So this new vector will perpendicular to A. Alright? So this is a vector perpendicular to A. So remember, if two perpendicular vector, the dot product is 0. The dot product of two perpendicular vectors equals to 0. Okay? So this one related to dot product. Alright? Okay, B. Simplify this one. Okay, B minus A bracket cross B. So we are going to use the distributive law. Alright? To use the distributive law to simplify it. So vector B cross vector B minus vector A cross vector A. Vector A cross vector B. Alright? So what is B cross B? B and B definitely parallel, right? So the cross product of two parallel vector is equals to 0. Alright? So 0 minus A cross B. So but you remember just now we say the vector product is non-commutative. So negative A cross B same as B cross A. So this is the simplest way, simplified. Alright? Okay, next question C. Simplify this. A minus B cross B minus A. Alright? A minus B cross B minus A. Okay? So how to simplify? So by using distributive law also, we start with A. So A going to cross with this. So A cross B. Alright? Minus A cross A. Okay? Then minus B cross B. Okay? Then plus negative B cross negative A. Alright? Okay, so again, A cross A 0, B cross B 0. Okay, so left A cross B. Okay, so negative B cross negative A actually same as B cross A. How I get this? So let's look at this diagram. So let's say this is A cross B lah. The red color one, A and B. So A cross B will be this one, the red color pen, the third. Sorry, it's the third. This is the red color pen will represent A cross B lah. All right. So if this is A, this is B. So the red color pen will be A cross B. Okay. So let's say I have negative A. So A to this direction. So this is negative A lah. B to this direction. So this is negative B lah. Okay? Alright? So if I use negative B cross negative A, negative B cross negative A, so same, right? The vector product is also perpendicular. The same vector, right? Okay? So from here, I can make a conclusion. Negative B cross negative A, same as B cross A. Alright? Because you see negative B cross negative A this direction. B cross A also the same direction. Clockwise direction. Okay, so from this diagram, I can say that negative B cross negative A same as B cross A. Or we can say A cross B same as negative A cross negative B. Okay, so this is something new lah. Okay, so A cross B plus B cross A. And B cross A is negative A cross B, right? Non-commutative, remember? B cross A is A cross B. So A cross B minus A cross B, 0. Alright? So I have simplified A, B, and C. Okay, pull down a bit. Alright, so I have simplified A, B, and C. So I want you to complete D. A minus B cross A plus B. Simplify them and get the answer. Alright? Okay, next, question 6. Okay, question 6. You are given A plus B plus C equals 0. Or A plus B plus C equals 0. Show that A cross B same as B cross A same as C cross A. Or A cross B same as B cross C same as C cross A. Show this one. Alright? So this is given. Okay. So look here. Look at here. Alright. A plus B plus C equals 0. Actually, when you see A plus B plus C, remember the resultant vector? So it's actually a triangle, you know. This is vector A. Plus B means followed by B, right? Right? Then plus C. Plus C. Followed by C. And it's equals to 0. Equals to 0 means you go back to the initial point. We start from this initial point. A plus B. When plus C becomes 0, so means you go back to this one. So your C is this one. Yeah, see or not? So when you are given, okay, well, from what we have learned previously, so if you are given A plus B plus C equals 0, so you know that actually A, B, C form a triangle. Alright? But this is not our purpose lah. Our purpose is to show A cross B same as B cross C same as C cross A, right? So I rearrange this one. This is given, right? A plus B plus C equals 0. So I rearrange. A is actually negative B minus C. I shift B and C to this side. Alright? Then I start with A cross B. What is A? A is negative B minus C. So cross B. So use distributive law, we expand. So it's negative B cross B minus C cross B. Right? So negative B and B are parallel, even though opposite direction, but still parallel, right? So the cross product for two parallel vectors, 0. Okay? And negative C cross B. Negative C cross B is same as P cross C. Alright, so from this part, we already showed that A cross B same as B cross C. Let's name it this one 1. Okay? Then, I rearrange this one again. Now, I left B as subject. A and C are shift to the right. So, B is equals negative A, negative C. Alright, so I start with the same thing. A cross B. Alright, so A cross, this is B. Alright, then using distributive law, A cross negative A minus A cross C. Alright, so again, A and negative A parallel, so 0. Okay, so 0, negative A cross C. So negative A cross C same as C cross A. So the second part, I have proved that A cross B same as C cross A. So equation 2. Okay, now you compare. This is A cross B. This is also A cross B. So 1 and 2 should be the same. Alright, therefore A cross B same as B cross C and same as C cross A. You can see. Okay, go out a bit. Alright, okay. Can I? So equation 1, A cross B same as B cross C. Equation 2, A cross B same as C cross A. Both also A cross B. Therefore, A cross B same as B cross C same as C cross A. Alright, proof. Okay, now the last one, question 7. Alright, so question 7, you are given two vectors A and B. So B only IK lah, J also 0. Okay, A, find the value of sine of the angle between A and B. Now you see, this one, they want you to find angle. and find a unit vector which is perpendicular to A and B. Okay, so this is question 7. Like this. Okay, we'll make it smaller so that you can see the whole solution. All right. Okay, so you are given vector A, vector B. All right, so because I know that this is the formula for A cross B. All right, so I know that I need to calculate A cross B lah. So again, use the same method. IJK, so 113, 2, 0, 1. Okay, so use the determinant method. Calculate the IJK. All right, then you get that A cross B is 1I plus 5J minus 2K. Okay, this one I can skip. You can go through yourself. Okay, so this is A cross B, a new vector. So the modulus for A cross B will be, remember the formula for modulus, 1 square plus 5 square plus 2 square. So square root 30. All right, so by using this formula, A cross B is modulus A, modulus B sine theta, unit vector n. So just add the modulus only. Okay, so this is unit vector so the modulus is 1 so we can just skip it. Okay, so the question 1 to find the sine theta, or the value of sine. So no need to find the angle, but they want the sine of the angle. Okay, so rearrange. Sine theta will be modulus A cross B. These two shift this side, become modulus A, modulus B. All right, so modulus A cross B just now here calculate already, square root 30. Okay, here we calculate modulus for A, square root 11, modulus for B, square root 5. So sub all these three values here. Okay, so simplified. So sine theta equals to 6 over 11. So the question only wants sine theta. So if the question wants you to find the angle, then you just press again calculator lah. Or theta is at sine 6 over 11. Alright, but this question, they just want the value of sine theta. They don't ask you to calculate the theta. Alright, so remember, if you are asking to calculate the angle, so angle in degree, only 1 decimal. Remember, angle in degree must be 1 decimal. Alright, so B, you are asking to calculate a unit vector which is perpendicular to A and B. Means n lah. Alright, means unit vector n. So this is the vector A cross B. This is the vector perpendicular to A and B. So the question 1 unit vector, right? So remember to calculate unit vector, 1 over the modulus of this vector. 1 over modulus, then multiply the vector. So remember, simplify, then we get this thing. This is a unit vector. That perpendicular to vector A and B. Oops. Okay. Okay. So this is basically related to vector product. All right. So yeah. Try to complete it by today lah. Okay. Your homework will be checkpoint 6.3. Checkpoint question 1C. Just now A, B I have discussed. Then question 2, 3, 4, 5D. A, B, C I have discussed. So you complete 5D. Question 6 no need. Okay. Question 6 I have discussed. All right. Then go back to your example 6136A. Page 17. This one. This one. Okay. There's 2 more questions here. Complete these 2 questions also. This one show that vector U and vector V parallel. How to show parallel? Find the cross product and it should be equals to 0. Okay. Then number 3 is find the angle between A and B. So you are given to find the angle. So find the angle. Same like this one. Same like this part. Okay. But this one, the question 1 angle, right? So you cannot stop here. You have to calculate the angle. Alright. Okay. So try to complete by today. I think tomorrow I will give you another short one. Alright. Okay. Thank you, class.